there we go. We got it. Now, negative 2.167789, or we can actually have here 3 decimal na lang. Pwede na yan. So, kung gusto nyo, dalawa. Okay lang naman yan. Same lang naman ang conclusion. So, negative 2.168. Okay, good day everyone. Welcome to our next discussion. For this topic, we will going to have the hypothesis testing, two population, testing the difference between two proportions. So this will be our last subtopic regarding the two population of the hypothesis testing. Okay, so again, testing the difference between two proportion. First of all, when we say proportion, this is actually, we're just saying that a certain point of interest is a part of a whole. That is a proportion. So, let's start our discussion. Testing the difference between two proportions deals with the procedures for drawing inferences. Take note for the term drawing inferences about the difference between populations whose data are nominal. So, therefore, we will going to have here on this topic a different nominal group of data, two populations of data, which is, again, we will going to have the inference coming from those two different proportions. Okay? Now, the number of applications of this statistical technique is almost unlimited. So, for example, in quality control, comparison of the defective rate between two manufacturing machines. So, we are comparing the defective rate, and those two manufacturing machines are actually independent from each other. The machine 1 doesn't care with machine 2, machine 2 doesn't care with machine 3. Okay? That's why we are having here the proportion, since we are concerned with the defective rate of both the machine 1 and machine 2. Next, for the second example of applications of this topic. For the pharmacists testing new drugs by comparing the new and the old one. That is the proportion 2. Another, marketing specialist comparing the market share before and after the advertising campaigns through televisions. So that is also a proportion. So for the formula of z-test for comparing two proportion, we will be having our formula. Just take note for the formula, guys. Let me just have my black pen. Okay, so this will be our formula. Z equals p hat sub 1 minus p hat sub 2 minus the difference of p sub 1 minus p sub 2. So here, p hat is the proportion, and the p is the what we call the population. Okay, so let's have the denominator over. Let's have the denominator square root of. I hope you're taking your notes, no? P bar and Q bar. Now, P bar and Q bar is actually, this is the proportion of the summation of the x's as the numerator and the summation of the n, or the number na sample sizes of what the population for the denominator part. Okay, so that is for the P. And for the Q, of course, Q is just the 1 minus P, the answer for the 1 minus P bar. Okay, so this will be multiplied to 1 over n sub 1 plus 1 over n sub 2. So this will be our formula for this topic, where P bar, this is what I'm actually referring a while ago. P bar is equals to x sub 1 plus x sub 2, the point of interest from the first population and the second population, divided by the summation of their sample sizes, which is denoted by n sub 1 and n sub 2. Okay? And Again, Q hat is equals to 1 minus P hat. And rather, Q bar is equals to 1 minus P bar. Bar is different from hat, guys. For the hat, this is what the formula looks like. So, P hat sub 1 equals X sub 1 over N sub 1. So, again, P hat means the proportion. Here, we have P hat sub 1 equals X sub 1 over N sub 1. Meaning to say, this is the proportion of the first population. Okay, I hope you get it. Again, first proportion of the first population, X over N, or the point of interest over the sample size. That is for the P hat sub 1. Of course, for the P hat sub 2, we have X sub 2 and N sub 2. Okay, I hope you get it. Next, for the assumptions of the z-test for comparing two proportions, first assumptions that we have here is that subjects are randomly selected and independently assigned to two groups. Just like the defective rate of the machines that I have actually given you as example a while ago, that is independently assigned to two groups, and the groups are the machines. Okay, so I hope you get it. Number 2, the data are in nominal level. So, not ordinal but rather nominal. Number 3, each sample is at least 10 times as big as its sample. Number 4, each sample includes at least 10 successes and 10 failures. Actually, some textbooks or some statistical references saying that 5 successes and 5 failures are enough. But for our discussion, let's try to have it 10. 10 successes and 10 failures. So, let's have an example here for this problem. So, for the example, we have a sample of 240 store customers, 72 used Visa card. Okay, so that is actually a X, out of the 240, this is actually can be considered as 10 and this is X. The question is this the first population or the second one? Actually, we can also we can already consider this as 1 since it is the first part of the problem, first sentence. Again, I repeat, in a sample of 240 store customers, 72 used Visa card. So, 72 over 240, that will be the proportion for the first population. Next, in another sample of 190, so this will be the second population, we have 190 as N sub 2. 76 from those 190 population used MasterCard. So, this is X sub 2. At alpha level 0.1, is there a difference in the proportion of people who use each type of credit card? Now, is there a difference between the proportion of people who are using Visa card versus who are using the MasterCard? Now, may difference ba? May pinagkaiba ba sila? Ayun yung hinahanap ng tanong. So, at alpha level 0.1, let's have the answer. Yes, there is, or no, wala. No, walang difference statistically. Okay? So, let's have our hypothesis first. For the hypothesis, we will be having here na null hypothesis natin will be P sub 1 or the first population is equals to the second population. So, we are saying here na walang pinagkaiba. Kasi inequal natin meaning equal si first population sa second population. Wala silang pinagkaiba. For the alternative hypothesis, we have here P sub 1 is not equal, rather, P sub 2. And as you can see, let's go back to our problem. The question here on the last part of the problem, at alpha level 0.1, is there a difference? Is there a difference? No, may pinagkaiba ba in the proportion of people who use each type of credit card? Is there a difference? Meaning to say, what I'm trying to say here is that this will be the alternative hypothesis. This will be our claim. No, kasi ayun yung parang tinutukoy ng ng dulong part. Meron bang pinagkaiba? And when we say may pinagkaiba, they are not equal. Okay? So, once our null hypothesis has been rejected after our solution, then tama yung claim. Pero if our null hypothesis is actually failed to reject siya, ang lumabas sa ating solution, mali si claim. Okay, ganoon lang naman ka-simple ang logic nito. So, next, we have the level of significance. Sabi doon, ang gagamitin natin level of significance is 0.10. Next, we have the z-critical. Ito na. Now, pagdating sa z-critical value, we have here the table. So, based on our given, as you can see on our given, we have here value of the level of significance, which is 0.1. And we forgot to have our tail test. Since we have here the null hypothesis as equal sign yung ginamit natin, alternative hypothesis not equal naman, meaning to say this will be a two-tailed test. Dahil wala siyang direction na binigay, either going to the right or going to the left. So, meaning to say, ang z-critical natin will be based on 0.1 and sa two-tailed test. And since ang ginamit natin na sample size is ito, we have 190 for the second population or for the second sample size, 240 yung second. They are both higher than 30, meaning to say, this will be a z value. No, that's why ito yung gamit natin, z-critical, hindi siya t. And we don't have here degrees of freedom. Okay, I hope that is clear with you. Again, 0.1 and two-tailed test. So, let's check it. Kapag two-tailed and walang confidence interval, no, dito tayo titingin sa pinakababa. So, we have 0.1, tapos two-tailed test, then pinakababa. Since, again, this is not a t-test dahil, wala tayong degrees of freedom. So, this will be the answer. See, 1.645. And since, guys, take note of this. Since this is a two-tailed test, our z-critical will not just be 1.645, but rather it will be positive and negative 1.645. Plus minus 1.645. No, meaning, the rejection region can be seen on the both tails of our normally distribution curve. Okay? So, let's have now our z-test value. So, our z-test value, again, for the formula, I'll just write it again. We have here p hat sub 1 minus p hat sub 2 minus the difference of p sub 1 minus p sub 2 over, we have here p bar multiplied to q bar multiplied to 1 over n sub 1 plus 1 over n sub 2, and all the denominator is under the square root. Okay, so let's check. Do we have now the value of p hat sub 1? So, do we already have the value of p hat? Actually, based on our previous formula, when we say p hat sub 1, that is x sub 1 over n sub 1. And we don't have it yet. So, meaning to say, let's solve first for the value of p hat sub 1, p hat sub 2, and of course, the p bar and the q bar. Because all of these numbers that we will be having or we will be getting upon the solution, during the solution, ay gagamitin natin dito sa loob ng ating z-test computation. Okay, so let's write then yung mga formula na ito. Sige, so let's start. Again, p bar equals x sub 1 plus x sub 2 over n sub 1 plus n sub 2. And q bar will be 1 minus p bar. For the p hat sub 1, we have here x sub 1 over n sub 1. For the p hat sub 2, we have the x sub 2 over n sub 2. So, let's solve first for the value of p bar. Let's start p bar. So, p bar is x sub 1 plus x sub 2 over n sub 1 plus n sub 2. So, for the p bar, x sub 1 value, what is x sub 1 value? X sub 1 is 72. So, let's write it here, 72. For the x sub 2, what is the value of our x sub 2? We have 76. So, 76 here. For the denominator, n sub 1 and n sub 2. N sub 1 is 240, n sub 2 is 190. So, 240 plus 190. Let's write them here. 240 and 190. So, P bar, let's have our calculation. I hope you have your calculator with you. 72 plus 76 over 240 plus 190. This will give you, in your calculator, this will give you an output of 0.344. And if that is our P bar, for the Q bar, again, simple lang naman, 1 minus P bar, itong Q bar. So, Q bar will be 1 minus 0.344. This will be, upon calculating, 656, 0.656. So, this will be the value of the Q bar. Now, for the values of P hat sub 1 and P hat sub 2, let's have the formula. So, P hat sub 1 equals x sub 1 over n sub 1. X sub 1 is, we have here 72, n sub 1 is 240. 72 divided by 240, this is 0.3. So, this is the value of P hat sub 1. For the P hat sub 2, this will be x sub 2 over n sub 2. Value, x sub 2, we have 76. Over n sub 2, we have 190. So, 76 over 190, this is 0.40 upon sa calculator niyo. So, 0.40 ang value ng ating P hat sub 2. Meaning to say, since we have already the value of P bar, we have the Q bar, we also have the P hat, and the P hat sub 1 and sub 2, we can now solve for the value of the Z. So, for the Z value. So, again, Z is walang katapusang rewrite ng formula dahil kulang ang ating space. So, Z, i-rewrite ko ulit. P hat sub 1 minus P hat sub 2 para na rin maalala ninyo. So, population 1, population 2. There is something na halos kapareho ng mga ginagawa natin, mga nangyayari sa mga formula sa previous na topic natin. I will let you know after ko ma-write ito. So, 1 over n sub 1 plus 1 over n sub 2 and square root. Okay, ito na po siya. P hat sub 1, this is 0.3. Minus P hat sub 2, this is 0.4. Minus, this is population 1 and population 2. That's why we are using, kung mapapansin ninyo, we are using this variable sa ating hypothesis. And ito yung gusto nating malaman, may difference ba yung dalawang population or wala? Gusto pa lang natin siyang malaman Wala pa, for now, wala pa silang difference sa atin dahil wala tayong value Wala tayong data. P sub 1 minus P sub 2 will be 0. I hope you get it. This is almost the same concept kung paano natin siya in-explain and ginawa sa mga previous natin na discussion regarding to the population hypothesis testing. Okay, so square root of, let's have our P bar and Q bar. So, P bar and Q bar natin, 0.344. So, let's write it here, 0.344 multiplied to the value of Q bar, which is 0.656. 0.656 and over 1 multiply to 1 over n sub 1 is 240 plus 1 over n sub 2 which is 190. Okay, now upon sa calculator ninyo, so I have here my calculator. Let's have fraction bar and laki-lakihan natin para makita ninyo. So ayan, so 0.30 minus 0.40 0.30 minus 0.40 minus 0. O, liitan natin. Masyadong malaki pala. Sorry. And ang denominator, we have the square root sa denominator. Multiply natin doon is 0.344. So, 0.344 multiplied to 0.656. 0.656. And multiplied ulit to the fraction naman. So, let's have here the fraction bar. Tapos, isa pa. May plus dito, no? Dahil dalawa sila eh. Dalawang population. So, ayan. 1 over n sub 1, which is, that is 1 over 240 and 1 over 190. So, 1 over 240. And the other one is 1 over 190. Okay, so here we go. We got it. Now, negative 2.167789. Or, we can actually have the 3 decimal na lang. Pwede na yan. So, kung gusto nyo, dalawa. Okay lang naman yan. Same lang naman ang conclusion. So, negative 2.168 if 3 decimals tayo. So, let's write here. Z score or Z computed is negative 2. Oops. I'll just delete this. Nadulas ng aking kamay. Okay. So, we have negative 2.168. Negative 2.168. Ayan. Ito ang ating Z computed. Now, since that is our Z computed, we can now move on sa ating decision rule. So, tingnan natin. Ito ang ating magiging curve, no? Same sa dati. Ang gitna is 0. Okay, so we have the two-tailed test. Ito, kabilaan siya. Ito ang rejection region. Tulad ng dati. Okay. We have this rejection region. And ang value netong Z critical based on our Z critical na nakuha kanina is 1.645. No, on both sides, positive and negative. So let's write it here. Positive 1.645, 1.645, and negative 1.645 for the critical value on the right and the left tail. Now, our computed value for the Z is negative 2.168. Nasaan yun sa ating curve? Dito, mas malayo sa 0. No? Mas malayo pa nga sa, dito sa negative 1.645. So, let's write it here. We have negative 2.168. And as you can see, tulad ng dati, since our computed value is nandoon sa loob ng rejection region, therefore, we need to reject our null hypothesis. Always null ang ating kailangang i-reject, no? And hindi si alternative. So, reject null hypothesis. Since our computed negative 2.168 is less than negative 1.645, which is our Z critical value. And if we look back on our hypothesis, since nireject natin ng ating null hypothesis, so this has been rejected, therefore tama ito, and sumakto nandoon na naman ang ating claim. Tama na naman ang ating claim. Therefore, yung kiniklaim nito ng problem na meron bang difference doon sa proportion of people who uses the Visa versus the MasterCard? No, ang sagot is yes. There is a difference since ang alternative hypothesis ang tama sa atin. Okay, I hope you get it. That is the basic analysis, pinakasimpleng pinakasimpleng analysis, no? Huwag niyong kakalimutan 'yan. So, statistically speaking, our conclusion will be, since we reject the null hypothesis, we can conclude that there is enough evidence to support the claim that there is significant difference in the proportions of Visa and MasterCard usage, again at alpha level 0.1. lagi natin nilalagay sa dulo yung alpha level dahil there is actually a chance na mag-iba yung interpretation and also yung conclusion kapag nag-iba yung gamit natin na significant level. Okay, so I hope that is clear with you. And actually, sana malinaw talaga, napaka-simple naman ng explanation, napaka step by step, no, and detailed. I hope nakuha ninyo. No, so that ends up our discussion regarding the hypothesis testing to population, testing the difference between two proportion. And this is actually the end of our chapter regarding hypothesis testing to population. So our next topic will be all about correlation and regression analysis. I hope you learned something from this presentation, guys. See you again online on next week or on our next presentation. And of course, keep safe always. Enjoy the rest of the day and of course, the rest of the week. Bye-bye, guys. See you.